Game theory is the study of strategic decision-making. It is a core aspect of how blockchain systems are designed so that anonymous nodes all over the world can work together for the common good of the network. Essentially, you want to design systems so that everyone acting in their own self-interest will help the network, not hurt it. This prisoner's dilemma is the classic example of game theory, so we'll run through it really quickly here to help clarify our statement. Alice and Bob are both caught at a crime scene and brought in for questioning. Under the law in this imaginary world, there are 4 possible outcomes here. Alice and Bob both confess, one or the other confesses, or neither confesses. Everyone's punishment length will vary depending on who does what. For example, if Bob confesses and Alice does not, then Alice gets to walk free and Bob takes the fall. If they both refuse to talk, they'll both go to jail for not cooperating. If they both confess, they'll get a lenient sentence for wrapping this whole thing up quickly. You can see all of the outcomes on this chart here. The worst outcome is highlighted in red, the one-sided outcomes in yellow, and the best outcome in green. Now, in a perfect world for Bob, he can stay silent and hope that Alice confesses. If that happens, he gets to walk free. But what if Alice also stays silent? Then they both get a fairly bad outcome. In this imaginary legal scenario, the law is designed to make confessing to your crimes the ideal outcome. It saves everyone time, and you get the most lenient sentence. Sure, you could roll the dice and stay silent, but the consequences could be dire. So the system is encouraging a specific outcome, an outcome that's good for the people operating on the side of the law. Let's translate this to blockchain. How does the Bitcoin network set up its system so that the best outcome for the individual is also the best outcome for Bitcoin? The most direct parallels we can see are in mining and block rewards. In the Bitcoin network, miners receive a Bitcoin reward for successfully compiling a block of transactions. All of the miners in the network are simultaneously trying to do the same thing. A key aspect here is that rewards are only recognized on the longest chain, meaning that if you somehow cheated your block and it invalidates one that follows, your rewards are gone. All that being said, let's start with the worst outcome. If everyone is cheating constantly, trying to throw together any old invalid block, then they're wasting their time. There will be no valid chain and no valid rewards. Everyone loses. On the exact opposite end of the spectrum, if everyone works honestly, everyone has an equal shot at the reward. Nobody wastes their efforts, and you're bound to see a fair share of the rewards. The edge cases here are when individuals try and cheat. If the majority of the network is honest, then you're simply improving their chance at the rewards while you're removing their own. Your reward drops to 0, and the rest of the networks improve. The Bitcoin network has created a system where any amount of cheating becomes a big waste of time. The only chance you have at getting a reward for your actions is if you work in the best interest of the network. Again, none of these concepts are particularly new. It's just that blockchains like Bitcoin have employed them in new ways. Game theory has successfully incentivized a network of thousands of nodes to work together despite not knowing each other at all.